Can you guys see my white screen?
Yeah.
Okay. I had something strange going on, so. Okay, so section 6.6. Systems of inequalities. So what do you think a system of inequalities? What do you think you have to do if you're solving them? You say you graph them on the same graph? Yes, that's correct. And you see where they intersect. So if we have this equation, or this inequality, and this inequality, we can graph those on a graph with a y-intercept of 4, a slope of -1, and this is a dotted line, and it's y values that are less than that, so it's going to be shaded this side. And this one is a y-intercept of 1, a slope of 1, and that's a solid line. And shaded this way because its y is less than or equal to. So where the two overlap is where our solution occurs. So this section down here is our solution set. It's bounded on this edge by a dotted line because it's strictly less than, and it's bound on this side by a solid line right up to that point. So it's anything in this set. So for today, you're going to be graphing at least 2 inequalities on the same set of axes, and you're going to be getting the shaded section, the section that both of them go into. Now, if I asked you if 2, 1 was a solution to this, you would have to check each one of those inequalities. So put 2, 1 into the first one, and you get 2 is less than negative, how about I start over here? How about 1 is less than a -2 plus 4 is 1 less than 2. And yes, it checks there. If I put it into the bottom equation, 1 is less than or equal to 2 plus 1. 1 is less than or equal to 3. Yes, it works there. So 2, 1 is in the solution set. And if I look over here where 2, 1 is, 2, 1 is right about there. I use a different color. It's right about there. So yes, it's in the solution set. So therefore, it works. Questions? What happens if they would have given you a point? Let's look at these equations and graph them real quick. Y is greater than -x plus 1, and y is greater than x minus 1. So when I graph those out, the first equation is going to be a y-intercept of 1, a slope of -1, so down 1 over 1, dotted line. Y is greater than x minus 1, so that's going to be a y-intercept of -1 and a slope of 1. And that's going to be a dotted line. I forgot to shade, didn't I? I want y values that are greater than that, so I want to go above the line. And on the first one, I wanted y values that are greater than that, so it's going to be above the line this way. Is the point 0, 0 part of the solution set? 0.00 is right here. It's not part of the red. It is part of the blue though, but it's not part of the red. So it's not in this solution set here. It's outside. So we would say no, even though it works for one of the equations, it doesn't work for both. So it's not part of the solution. I really don't think there's much more to go over in this section because the hardest part of these ones are graphing the equations, and you have Desmos to graph them for you. So it's more of interpreting the equations at this point. Do you guys have any questions?
So if with the point given, you only say it's part of the solution set if it is where the red and blue intermits?
Yes, correct.
Right.
You can still have no solution. So if I had parallel lines that I was graphing and this one was shaded this way, and I had another parallel line down here, and it was shaded this side of that parallel line, there still would be no solutions to this system of equations. Now, if I had the shading the opposite way with those parallel lines, the solution set would be the set that's in between those two. So you always, whenever you have a system of equations that has a solution set, there's an infinite number of points, but you have to show those infinite number of points by shading the region that those points are in. But you can have regions, or you can have a solution set with no solution. Okay? Questions? Okay. It's going to end up being 16 through 34 even. On page
I have a question.
424. Yes.
How do we know what to shade? Is it like, how do we know to shade greater than or less than?
Okay, so I always go off of the y-intercept. I say if I'm here on this y-axis and it says y is greater than, where are values of y that are greater than that y-intercept? Up here. So that's what I use as my way of shading. If so like for this one here was my y-intercept. I shaded above that y-intercept. Here was my y-intercept. I shaded above it, but your line is going to tell you whether you're on an angle to the right shading or on an angle to the left shading. Does that make sense, Lucas?
Yeah.
Okay.
Mrs. Reed,
Yes.
could there be a problem where the lines are on top of each other and then the shading goes either way, so like the whole graph would be shaded?
There could be it wouldn't be that the whole graph is, well, yeah. So if you have two lines, let me give you one. Y is greater than x plus 4. I'm going to change the color of this one. And y is less than x plus 4. So you have those two equations like that. So they both have the same y-intercept of 4. They're a dotted line with a slope of 1. This blue one, we want y values that are less than that. So here's my y-intercept. I'm less than it, so I'm going to be shading down here. And then when I go back to the other equation, it has a y-intercept of 4. and it has y-intercept of 4, and it has a slope of 1, and it's dotted, so it's that same line. But we're shading, we want y values that are greater than it. So it looks like the whole graph is shaded, right? But this actually has no solutions. Because the only place that they cross would be on that line, and neither one of those include the line. Even if one of them included the line, it still would be no solution because the other one doesn't include the line. Does that make sense, Zach?
Oh, yes.
Okay. If I throw that on there, then my solution set is just the line. Other questions? All right. So page 424, 16 through 32 even. Have a great day.
Thank you.